All right. Welcome to the Explainer. Today we're going to tackle a concept that honestly can be a little tricky for a lot of folks in the Kubernetes world. We're talking about ingress. Think of it as the smart gateway, the traffic cop for your cluster, directing everything from the outside world to your applications. And trust me, getting this right is a total game changer.
So let's just dive right in. Have you ever been working with Kubernetes services and just thought, is this it? Is it really this basic? If you've ever tried to expose your apps to the world, you probably know that feeling. It's like something's missing, especially if you come from a world with traditional load balancers that have all those cool advanced routing features. Okay, to really appreciate why ingress is such a big deal, we kind of have to go back in time a bit. Let's look at life before ingress even existed. We're talking before Kubernetes version 1.1. Back then, if you wanted to get traffic to your applications, you had one tool and one tool only, the service object.
And look, don't get me wrong, services are fantastic for what they do. They're great for internal service discovery, and yeah, they can get you a public IP to expose your app. But, and this is a big but, as bigger, more complex enterprise-level applications started moving over to Kubernetes, developers started hitting some major walls. We're talking serious limitations, not just in missing features, but also in some pretty shocking costs.
And really, these limitations created two massive headaches for any team trying to run a real multi-service application at scale. First, there was this huge gap in features, and second, the cloud build just kept getting bigger and bigger.
And this slide right here, this really hits the nail on the head. See, developers were used to these really sophisticated load balancers, ones that could do smart things like route traffic based on the URL path, like sending everything for /API to one place and /dashboard to another. Or they could send requests for api.myapp.com to a completely different set of servers than www.myapp.com. But the default Kubernetes service, all it could do was a simple round robin. It just felt like taking a giant step backward in time.
Yeah, this quote from Abhishek Viramala just says it all, right? People were coming from these VM-based worlds where they had all this power. I mean, think about the absolute must-haves for any real app. You need SSL/TLS for security, you need sticky sessions so your users don't get bounced around, all that advanced stuff. With just a basic service, poof, it was all gone. And this wasn't just a small annoyance. For a lot of teams, it was a total deal-breaker for running anything serious in production.
And then came the second headache, the one that really hurts. The cost. See, every single time you create a service of type load balancer, your cloud provider happily spins up a brand new dedicated public IP address and then sends you the bill for it. Now imagine you have an architecture with hundreds or even thousands of microservices. That cost just explodes. It's like you're paying for 1,000 different front doors to your house when all you really needed was one smart, well-managed entrance.
Okay, so clearly something had to change. Kubernetes needed a much smarter solution. And the community came up with this really elegant two-part answer. Let's start with part one, a brand new type of Kubernetes object called the ingress resource.
The best way to think about an ingress resource is as a rulebook, or maybe a map. It's really just a chunk of YAML where you state your intentions. You're just writing down the rules. Like, hey, when traffic comes in for this hostname, I want you to send it over to that service. But, and this is super important, the ingress resource itself doesn't actually do anything. It's passive. It's just the plan.
And this is where all the power comes from. You can get super specific with these rules. You can literally say, okay, all traffic for api.example.com, that goes to the API service. But any traffic for example.com/analytics, nope, that goes over to the analytics service. You can even tell it exactly which TLS certificates to use to secure your traffic. It's all declared right there, neatly in one central spot.
Okay, so if the ingress resource is just the map, just the set of rules, then who's actually reading the map and directing the traffic? Great question. That brings us to the second and very active part of the solution, the ingress controller.
The ingress controller. This is the brains of the operation. It's the engine that makes the whole thing go. It's an actual piece of software, usually just another pod running inside your cluster, and its only job is to constantly watch for any ingress resources you create or change. The second it sees a new rule, it instantly reconfigures itself to start enforcing that rule. It's the traffic cop that actually looks at your map and brings it to life.
Now, here's what I think is a really clever move by the Kubernetes team. They didn't build one single official controller. Instead, they just defined the standard, the API, and let the experts build the actual implementations. So companies that are already masters of load balancing, like Nginx, HAProxy, or Trafic, they all offer their own controllers. This is great for you because you get to pick the one that has the exact features and performance you need.
Okay, so let's put all the pieces together. What does life look like after Ingress, once you have your rules defined in an Ingress resource and a controller making them happen? Well, it's a total transformation.
The whole workflow just becomes so much more efficient. Your cluster admin can set up the Ingress controller one time, just once. And from that day forward, your development teams can just create their own simple Ingress YAML files whenever they need to route traffic to a new app. They're totally empowered to manage their own routing, all while sharing that single central gateway.
And just look at the difference here. The benefits are just huge. On the cost side, you go from paying for a public IP for every single service down to paying for just one. That can literally slash your cloud bill. For management, instead of juggling dozens of random IP addresses, you're just editing simple, easy-to-read YAML files. And for security, what used to be a decentralized mess is now centralized and way easier to manage.
Let's talk about that security part for a second, because this is a massive win, both for security and for your operations team. Think about it. No more configuring TLS certificates on every single individual microservice. Instead, the Ingress controller handles all of that heavy lifting, all the encryption and decryption right at the edge of your cluster. It becomes that one single secure front door for everything.
So when you boil it all down, Ingress does an amazing job of solving the north-south traffic problem. That's the technical term for traffic coming from the outside world into your cluster. But solving this one problem so elegantly naturally leads to another question, doesn't it? What about the east-west traffic? You know, the communication between all of our services once they're already inside the cluster. Well, that is a fantastic question and a topic for another explainer.